In 1861, the discovery of the Archaeopteryx fossil offered compelling new evidence for Darwin's On the Origin of Species, published just 2 years earlier. What made this fossil so important was that it showed a transitional form, an animal with the skeletal features of a reptile, but with feathers like a bird. Thomas Henry Huxley later observed striking similarities between Archaeopteryx and dinosaurs. In 1868, he proposed that birds might have evolved from dinosaurs, a hypothesis that gained support from many scholars. However, in the 1920s, this idea was set aside. At the time, fossil evidence seemed to contradict a principle known as Dallow's law, which holds that once a complex structure is lost in evolution, it is unlikely to reappear. In 1969, Yale paleontologist John Ostrom discovered Deinonychus. His subsequent research revealed remarkable similarities between this dinosaur and Archaeopteryx, leading him to propose that birds evolved from a clade of dinosaurs called Coelurosauria. Ostrom and some of his colleagues even suggested that dinosaurs might have been warm-blooded, like birds. By 1980s, with the advent of methods like cladistic analysis, the dinosaur-bird hypothesis gained wide acceptance among scientists. Fossil discoveries from around the world continued to strengthen this theory, yet scientists were still searching for the most critical piece of the puzzle.
In 1996, we discovered the first fossil of Laureates in West Liaoning. The fossil was exquisitely preserved, allowing us to clearly see the filamentous structures covering its body. At first, we thought it may be a transitional form between dinosaurs and birds, perhaps the oldest birds in China, but later we realized its significance went far beyond that.
Sinosauropteryx was the first non-avian dinosaur found with clear evidence of feathers. It showed that feathers were not exclusive to birds, but likely widespread among theropod dinosaurs. This discovery provided the initial fossil evidence supporting the bird-dinosaur origin hypothesis and opened the door to a series of major discoveries in Liaoning, marking the beginning of the so-called feathered dinosaur era.
Were the filamentous structures preserved on the Sinosauropteryx fossils truly feathers? Since Archaeopteryx, the earliest known bird, lived during the Jurassic period, its dinosaur ancestors must have appeared even earlier. But why are fossils of bird-like dinosaurs so rare in Jurassic deposits? Beginning in 1997, we set out to find the answers, not only uncovering the more feathery dinosaur fossils from the Cretaceous period, supporting the idea that the filaments on Sinosauropteryx were indeed feathers, but also we discovered a series of feathery dinosaurs, such as Anchiornis, Epidenticipteryx, and Ichi, in middle to late Jurassic deposits. These fossils preserve a wide variety of feather types and showed that feathers appeared at least 10 million years before Archaeopteryx, helping to align the timing of bird evolution with the fossil records.
Zhou was the pioneer in applying large-scale phylogenetic analysis to the study of feathered dinosaurs. By placing newly discovered species into an ever-expanding evolutionary tree, he gradually filled in the gaps in our understanding of how dinosaurs evolved into birds.
Beyond the evolution of feathers, the origin of flight has also long been a topic of great interest. In 2003, Xu and I published our finding that Microraptor may have been a four-winged glider. It had wings not only on its arms, but also on its legs. This could represent a transitional stage in the evolution of powered flight in birds, or perhaps a failed evolutionary experiment. What's clear is that the flight-related anatomy of early birds was quite different from that of modern birds. I'm eager to understand the evolutionary rules behind this transformation.
Zhou has long been the world leader in research on extinct birds, and the rich fossil beds of western Liaoning have provided abundant material for his research. After 3 decades of dedicated work, Chinese paleontologists now possess ample evidence to demonstrate that dinosaurs never truly went extinct. One lineage survived the Cretaceous Paleogene mass extinction, living on today in the form of aves. For their discovery of fossil evidence for the origin of birds from dinosaurs, the 2025 Future Science Prize in Life Science goes to Qiang Ji, Xing, and Zhou.